When you're asked to graph a hyperbola and it's centered at the origin, first of all, you can tell from the equation that this is a hyperbola because you have x squared and y squared, and one of these is minus. So when that happens, you know it's a hyperbola. I also can tell from this equation that it's centered at the origin because I don't have any x or y term. We have our x squared term and our y squared term, but no x and y. So I know that this is going to be centered at the origin. Also, you can see down here that, so this would be the standard form of an equation centered at the origin, okay? And you can simplify this formula if to look like this over here, right? Because if y minus 0 is squared, then just y is squared, okay? And that goes for both cases. So remember, you have two cases here. You have the case where you have your y squared first, and then you're subtracting the x squared value. And I always think of, okay, when I'm thinking of graphing that, I think, okay, y squared's first. It's kind of wrapping around the y-axis. It's going up and down, like the y-axis does. Okay, and then same thing if x squared is first for my hyperbola, then it's wrapping around the x-axis, going in the x direction, so it's opening up right and left. Okay, so basically you need to put your equation in this form. And so basically, you're going to want to start by moving this negative 225 over to the other side. So we add a positive 225 to both sides. And then we want to make this equal to 1. So we can do that by dividing both sides of the equation by 225. And I'm going to go ahead and distribute my division to both of these terms over here on the left side. And then it's just a matter of simplifying. So you can divide 25 and 225 both by 25. So essentially what I do to figure out what needs to go there is do 225 divided by 25, and you get a 9. So this becomes x squared over 9 minus y squared over 25, because it turns out that 225 divided by 9 is 25, it goes down here, equals 1. Now I have it in standard form. You can see that the center here is 0, 0, if you didn't already notice that, right? And you can see that your a value is 3, and your b value is 25, excuse me, 5. Because b squared is 25, so the square root of that is 5. So that's b. And this is a squared is 9, so a is 3. Okay, so now remember when we're graphing these, we find the center. So in this case, we have the second case down here. So we find this, we plot the center, that's going to be at the origin, 0, 0. And then you can see you're going out to the right, and so that's in the x direction. So you're going to add your a value to the center to your x coordinate. Okay, so that means you're going to be adding this 3. Okay, and then remember we're going to make our box, so we're going to go out to the 3, right, from the center and up 5. Make our box and graph our little graph here. Okay, so let's look at that in ALEKS. So we click on the hyperbola button. We go out to 0, 0, place the center, and now we're going to place the vertex. So remember that this graph is opening up to the right, so we want to place the vertex going in this direction, not this way. So we were going out 3 units, and we place the point there. And now we want to create the triangle so we can determine this shape a little bit better, and so that was going to be a 5. So we go up 5 units from there and place that other point, and here you can see you have your hyperbola. Now let's look at another example. So this one, we have a negative x squared plus 4x minus 16 equals 0. Negative 4x squared plus y squared minus 16 equals 0. Let's make sure that I did that correctly. Yep. Okay. So now we're going to move the 16 over, negative 4x squared plus y squared plus, adding 16 to both sides is going to give us equal to 16. Now we're going to divide everything by 16. And you can see that this is going to give you a negative x squared over 4 plus y squared over 16 equals to 1. And so we can rewrite this as y squared over 16 minus x squared over 4 equals 1. So we know the center's at 0, 0. And we know this is a y squared, the y squared's first, it's positive, so this is going to be opening up. So our a value, or the value under the y squared, is what we're adding, right? So a, in this case, whoops, didn't mean to do that. So here we can see if a squared is 16, then a is 4. And here, if b squared is 4, then b is 2. So we're going to plot the center 0, 0, and then we're going to go up 4 units from there and down 4 units if we were graphing it on paper, right? And then we'd make the vertices. And then we make our box by going out 2 units from the center in both directions. Okay? So that's what we're going to do. Center 0, 0, A4, B2. So let's go over to ALEKS. Okay, and so we can see hyperbola, center at 0, 0. The a value was 4, so we go up to 4, plot that point, and then our a value is 4, b is 2, so we plot that point over here, and now we have a hyperbola that's opening up and down.